Join the revolution of open source software at the freecad and CAE Users Conference. Hosted by the University of Pretoria and powered by the Royal Academy of Engineering and Engineering X. From March 1st to 3rd, come together with a community of creators and users on the Hop-In platform to share knowledge, network, and learn about the latest developments in the world of freecad and CAE. It's a great opportunity to learn from experts in the field, network with like-minded individuals, and stay up to date on the latest developments in the world of open source software. The conference aims to bring the world of open source software closer to the public and showcase the potential of freecad and CAE through presentations, workshops, and interactive sessions. Attendees will have the opportunity to learn from experienced users and developers as they share their knowledge and experiences with the software.
Open source software, such as freecad, is changing the way we think about and use technology. Open source software offers collaboration, accessibility and innovation. In the field of AI, it leads to faster and more efficient development through collective work and sharing of knowledge. It helps democratize technology and make it accessible to more people.
The conference will take place on Hop-In, a virtual event platform that allows for live streaming, interactive sessions, and networking opportunities. Together, let's embrace the power of open source software and shape a more inclusive and innovative future.
The freecad and CAE Users Conference, where creativity knows no bounds, and distance is no barrier.
So I guess it's my turn to welcome you to this freecad Users Conference. I'd like to first thank everybody who organized this conference, Varnu and the University of Pretoria to host it. I will talk briefly about the state of affairs of freecad, where we stand, where we're coming from, and where we are going. So I'm yorik. I'm one of the main freecad developers. I'm also the president of the Freecad Projects Association, the new non-profit body we have developed around freecad. I'm an architect by trade. I do architect work. I do programming. I do 3D rendering, urban sketching, comics writing sometimes, etc. So I would begin with a quick history of freecad. Freecad, the development began around 2002. It was a two-person affair that started in Germany, basically when Open Cascade, which is the main component of freecad, got open sourced. Open Cascade is a gigantic geometry modeling kernel, and it has hundreds and thousands of functions and tools for doing anything related to geometry, manipulating solids, NURBS geometry, etc. And it's basically the basic building block of FreeCAD. Without it, probably a FreeCAD wouldn't be there, because programming a geometry kernel from scratch would be close to impossible mission. So the project grew steadily, with 2 persons working on it for years. In 2008 I joined the project. So it became a 3-people project. Basically I was in search of a way to do architectural work that wouldn't depend on the big software vendors, because I was working in a small office, and buying software license for both of us would have been like hiring another person, so it felt like impossible. So I began to search for free and open source solutions, and I stumbled upon FreeCAD, who was basically not much more than just a 3D platform with a big Python interface, and I thought, okay, that I could maybe help and do something. So during these years, a couple of other developers joined. In 2010 we have the big 3D printing boom. You begin to have 3D printers everywhere. Fab labs began to appear and to develop, and that's basically where FreeCAD began to be used a lot. And so the number of users and developers began to grow a lot. In 2020, Fusion 360 products by Autodesk began to put a lot of limitations to the users. You couldn't export your work anymore, and anything a bit more than basic that you wanted to do you would need to buy a license. So a lot of users of that product began to search for an alternative, and we had a big spike of users coming all at once in FreeCAD. With that came more interest in the media, etc., etc., and we had another expansion boom happening. And today, basically, FreeCAD has more or less 30 regular developers. I mean, people who contribute, let's say, once a week at least, or a couple of times a month. We have a non-profit body that I will talk about next. We begin to have funded development opportunities, like people can begin to work on FreeCAD and earn money for it, and FreeCAD is entering the corporate world. You begin to see companies beginning to use FreeCAD for internally for their work, and begin to look at it and involve themselves with FreeCAD. The non-profit body of FreeCAD is the FPA. We call it the FPA. It's the FreeCAD Project Association. It's a non-profit association that's built to support the FreeCAD community. It's not built to rule over FreeCAD. It's built to be a kind of side project to FreeCAD, or let's say a tool for the FreeCAD community. Basically what it does is gathering funds from donators. Lots of people and more companies want to help the FreeCAD project, but they cannot code, or they cannot put time into it, and they would like to support the project with money. So basically that's what this association is there for, to be a place where they can donate money, and it redirects that money to different kinds of uses and projects around freecad. So it organizes projects to use that money for example, to develop some parts of freecad, etc. It supports the developers. It helps the developer to do their job better. For example, paying for their time. And another important use of the non-profit is that it helps to protect the community-developed model of freecad. The community, I talk a lot about the freecad community because freecad is essentially a community project. It's more like the original freecad developer Jürgen said once, freecad is much more a social project than a technical project. Everything is made by the community in freecad. There is no boss. The community decides, the community organizes, the community puts things in place to make things happen. The community writes documentation, translations, and everything in freecad. And the community is made of developers, users, companies more and more, but basically users. Most big part of the freecad developers today are users who learned to code. And freecad is essentially a project developed by its users. The community also, each person who contributes to the code of freecad has ownership and copyright over that code. So the whole freecad code is actually owned by a lot of people, more than 200. And this is something that gives strength to freecad. You cannot buy something from 200 owners. It's basically impossible. And the community is constantly creating side projects, and so the whole ecosystem of freecad is growing and spreading a lot beyond its limits. A quick note about open source development model, which is the model of development of freecad. Basically, the basic assumption is that it's your software. You take it, you take the code, you take the software, and it's yours. There is no contract between developers and you, the user. You take the software, and its license is actually there to protect your rights instead of limiting what you can do with the software. Another very important point too is that the data you produce with the software, the models you produce with freecad, are also entirely yours, not only by license, but also the way the data is formatted. Freecad files, freecad models can be opened without freecad. It's basically the freecad file is a zip. You can unzip it and take the component inside it. Most of things are text-based files, and it's all open formats. So you could open a freecad file in 50 years from now without freecad, with another software. It's your data, and it's designed to stay that way and to be accessible to you, so that you won't lose any data over time, even if freecad would disappear someday. Lots of people think open source development is bad quality development, and we used to say it's actually the contrary. The way freecad is developed, the way features are validated, are checked, are analyzed by other people, the way bugs are always kept somewhere until they are solved. the way the code is checked for error, etc. All of these are methods, are very professional methods. The development methods of FreeCAD, the way FreeCAD is developed, being open source, is highly professional. I dare to say more professional than inside many software companies. FreeCAD also has a very large development team. It's not 3 people. It's hundreds of people who are developing code, who are testing code, who are suggesting changes, who are finding bugs, and who are documenting how the different features of FreeCAD work. There are not many software companies in the world who can gather such a team on a single project. All this gives actually a very high quality level of the FreeCAD code. And we also have several perks at FreeCAD, things that you wouldn't find so easily in commercial applications. Every file that FreeCAD reads and produces usually follows open format specifications. FreeCAD works a lot with open file formats. I say usually because it still can import a couple of proprietary file formats. But everything you produce with FreeCAD is open format. It can be read with other applications easily. It can be exported and easily imported in other applications. It can be opened and read with a text editor, things like that. Often in commercial software, compatibility is actually restricted. They want to keep their users into their own solution. In FreeCAD, we don't have this commercial interest. We like compatibility, and we want compatibility with anything possible to happen. So for example, FreeCAD exports and imports around 50 different file formats, and there are much more that can be plugged in, and so it's a lot of different file formats. We have backwards compatibility, that's kind of expected. And in FreeCAD, we also have something else that is forward compatibility. That's something you won't find so easily in commercial applications. That means that a file produced with a newer FreeCAD version can still be opened with an older FreeCAD version. So you could open a file produced today in a FreeCAD version of 5 years ago. And that is because they all follow the same structure. The file format is incremental. So only the new items that didn't exist in the 5 years ago version won't be there, but the file can still be read. And there is something fantastic when you work with FreeCAD and when you work on developing FreeCAD, is that you work with no deadlines, no pressure, no boss. Nobody who tells you how you must work. You decide how you best do your work, and you discuss with others if your work is overlapping or stepping or intersecting with the work of others. That's just a normal way to do things, but you decide on your own stuff, and that's something that's really a nice work environment to work with. So to talk a little bit about FreeCAD itself, the main feature of FreeCAD is parametric modeling software. Parametric modeling basically means that the FreeCAD objects are like little programs which are run every time you need to recalculate the shape of that object. So a box, for example, will be defined by length, width, and height. And every time you change one of those parameters, the program runs and recomputes the shape of the box based on these 3 parameters. And parameters can be anything, can be pieces of text, numbers, or even be something from another object, like a face of another object, or the length of another object, or something like that. So you can really begin to think of big parametric chains, where one object, like you have a line, and the length of the line drives something else, the whole shape or the position of other objects, or how big they are, or things like that. And you can have a couple of master objects who drive all the rest of your objects. The other advantage is that these parameter changes are easy to record. So if you change the length of your box from 2 millimeters to 10 millimeters, that's a very simple operation to record. That also means they can be easily undone. You set the parameter back to 2 millimeters, and the shape is recomputed back to when it has 2 millimeters. FreeCAD is also a generic modeler, and that's also an important thing. At the base is just geometry engine, a big geometry engine that supports solids and NURBS geometry. You can do solids, NURBS surfaces, NURBS curves, line work, meshes, annotations, text, dimensions, and bring into this a lot of other kinds, types of objects. So FreeCAD is really a very generic toolbox for geometry modeling. It has no specialty. All the specialties, for example, we have workbench to do woodworking, to do sheet metal folding, to do architecture and BIM, to do boat hull design, and those are all plugins around the core applications. The design of FreeCAD itself, how the code is designed, is very modular. The engine and the interface codes are separated. The code is carefully separated into different sections. There are boundaries between these sections. There are dependency. One part can depend on another, but the other cannot depend back on the first one. So you have a clean dependency tree. And mostly everything in FreeCAD is a plugin. You have a very small core that doesn't do anything, basically. Just opens a 3D window and allows to save and open files, and that's it. And everything else is actually a plugin. So you can have many developers working together, each one on their own parts of the code without interfering with the others. You have a quite low entry barrier. That means that someone new to FreeCAD and to coding can start by learning just a specific part of the code and grow their knowledge from there. And we have, thanks to that, a quite easy merging workflow where lots of different code change and contributions can be merged together without interfering each other. Another interesting feature of FreeCAD is that it has Python everywhere. Python is a very human-oriented programming language. It's really easy to learn, and that's a very important feature of a programming language too. It attracts a lot of users. Users can easily begin to code in Python, etc. In FreeCAD, the most of the core functionality is coded in C++, which is a much more efficient language. So everywhere we need efficiency and speed, it's coded in C++. But most of the outer layers that define the tools themselves, the interface, how things work for the user, are coded in Python. And also, that's an important point, all the glue between the core application and the interface is coded in Python. That means every time you press a button in FreeCAD, you're actually executing one line of Python code that goes to the core and that tells it what it has to do. And there are lots of easy and didactic tools in freecad, like you have a window that you can keep open at the bottom of your screen, where every time you click a button and that line of Python code is executed, you see it in that window at the bottom of your screen. So you end up learning how freecad works. You see that line of code and you could copy it and change it and make it happen yourself and put it in a script, and that's it. You're beginning to code for freecad, and that's actually how many of the freecad developers began to code, just by tweaking with this Python code there. So I'd like to finish by talking a little bit about what I personally am doing with freecad. Basically, my area of actuation in freecad is mostly centered around BIM, which are tools for architect, engineering, and the construction field. Do a very quick history of where we're coming from. Basically, up to today, actually, most of the work done in architecture, engineering, construction field is still done with 2D drawings. That comes from the time where you would draw directly on big sheets of papers and give this sheet of paper to people on the work site to build the building. In the 80s, we began to have the first 2D CAD systems, basically AutoCAD, which was and still is the main player in that field. Then these platforms began to gain 3D capacities, and finally we are now arriving at something they called BIM. BIM stands for Building Information Modeling. It's basically CAD for architecture, engineering, construction. Basically, BIM models are 3D models with more non-geometrical information in it. If you think that a drawing, which is still needed at the end, because what goes to the work site, what carries the information, what gives the information to people who actually build the building, still goes through drawings. They take the drawings, they look at drawings, and they build according to the drawings. It's still something made by persons, by humans, and so drawings are still a way we communicate to those people what needs to be built. A drawing is about 50% geometry and 50% annotations. This is size of thing, this is size of that, this is made of that material, this should go before that, that kind of information, which is not just lines and geometry. And the BIM model basically holds everything, or that's the idea, it's to hold everything inside the model that you would need to produce those drawings. So you would have like one model and you could extract those drawings automatically from it. So how is the BIM situation today? Now basically we have two companies owning almost 100% of the BIM software used in the world in architecture and engineering offices. So this is a worrying situation. You have both of these enforce closed ecosystems where they try to maintain their users hooked to their own solutions or a panel of solutions. And there are big companies driven by commercial interests. So the tools you use as a professional, as an architect, as an engineer, are actually decided. How those tools work are decided by a commercial team, basically. And that's something pretty worrying, that architecture especially is still a very, there is a artisanal aspect of it, that you as an architect are a crafter. You model things, you decide how you model things the same way as a lumberjack would be the best person to define how wood axe should be, how it should be shaped, where the weight should be, etc. So you as an architect should be the main person to decide how your modeling tools should be. And that's not what's happening with BIM software today. And even more worrying, you begin to see that the software, a simple Google search would confirm that to you. And all those models, that architecture produced with those software begin to look alike. So it begins to influence the way we do architecture, because the restricted set of tools force all users to go along the same ways and to adopt the same solutions. And that's definitely something where open source software can change things and make a big difference. In open source BIM, we already have several working solutions, solid working solutions. FreeCAD is one. You can already do complete BIM projects within FreeCAD. Blender BIM is another. IFC OpenShell is another piece of solid software that is used in an open source BIM ecosystem. IFC.js. There are many others. All of these pieces of software have very high interoperability, and they all communicate extremely well through each other. Most of the time because they use the same components, they have the same basis, but also because they use the same formats, and more even simpler than that, they want to interoperate. You have many specialties. You have software for modeling, for analyzing, for producing, all kinds of byproducts you need around. And there is one big file format used everywhere there, which is the IFC file format. The IFC file format is an open standard. It's managed by a consortium. It's extremely well documented. All the specification of what's inside that file format, how it must be formatted, is open sourced. It's well explained how you must compose your file, etc. And the IFC format itself is a text format. If you don't have any BIM application to open an IFC file, you could open it with a text editor, and you could read the lines inside and understand what's going on. You could very easily make a little program to extract the information that you need from inside an IFC file. It can even be rendered in a spreadsheet form, so you can look at an IFC building in a spreadsheet application. Have the quantities of doors, have the quantities of walls, etc., etc. And this is what I'm currently developing in FreeCAD. It's native IFC. The concept native IFC means being able to open and save IFC files in FreeCAD natively. That means without having to convert the data to FreeCAD internal model, to FreeCAD internal data structure, and then convert it back to EFC, because all these conversions make you lose pieces of data or even reorganize pieces of data. And so the idea is really work with the IFC data itself inside FreeCAD. That is already working in Blender BIM. Blender BIM uses native IFC concept already very successfully. So that means in FreeCAD basically that we don't use Open Cascade directly anymore. We use another geometry engine, which is IFC OpenShell, which is what produced the geometry you see in FreeCAD. So all the geometry you see and you manipulate in FreeCAD is always produced directly from the IFC file. So you change something in the IFC file, the geometry you see in FreeCAD is updated. And there are very interesting consequences to this, is that if you change one thing, the name of an object in FreeCAD, there is one place in the IFC file where is that it has changed. So this makes it very very friendly to version control. Version control system can give you 2 versions of an IFC file and show you where things have changed. So basically that's it. Thank you for watching. Here are a couple of links where you can reach me, or just Google me and you find more. Thank you, and enjoy the rest of this event.